Welcome to a tutorial on using ramspeed benchmark in the gem5 SST 2.2.1 environment. The idea here is that today that we're going to install a benchmark called ramspeed. So I just Google ramspeed and go to that first link. And this software is free. We're just going to download the Linux executable, source code. I'll save that and open the containing folder and extract it. And we're going to move that folder into our home directory. Alright, so as a consequence of all these manipulations, the end result is that we have the ramspeed folder extracted to our home directory. We're going to go into ramspeed. The contents there, the main thing that we care about are build.sh, so if we run that and we'll hit enter, it's just telling us that the commands are going to be wall o2 and w1 and o2. So there you can see the compiler ran, and as a result now we have the ramspeed executable here. The way ramspeed works is if you execute it, it needs some command line switches, specifically which test do you want to run. So we're going to choose just the first one, which is going to be an integer writing to file. And the test here goes through and does different sizes of message that's going to write. And these are larger and larger messages, and the speed is decreasing here. A plot of this would actually show the transition from register files to cache, to L1 cache, to L2 cache, and RAM. So our objective today is to get this program, ramspeed, to run in SST 2.2.1 with gem5. So in order to do this, we need to have a statically compiled binary. What that means is, although we have the ramspeed compiled here, it's 86 kilobytes, and so what we need is the statically compiled binary. So I'm just going to cheat and run build.sh again. What that's going to do is give me the commands I need to run to get the static binary. So I'm going to use these and then throw in -static. And now if we look at the size of that binary, it's a lot bigger, 767 kilobytes. But if I run it, I get the same behavior, so that's good. Alright, so now we want to make this run in gem5. Now if you'll recall from an earlier video, I showed you that the m5 environment, the m5 exe environment variable, which is a variable that we set, that was set to the application we want to run in SST. What I'm going to do is change that, so we're going to edit the bash rc. Gedit. And cleaning up our LD library path. It has to do with all the SST variables. And we're just going to replace this with ramspeed -2.6.0/ramspeed. So this is the path to the static binary. I'm going to save that and close it. I'll do source bash rc. And this will, now if we look at the value of the m5 exe variable, it's set to the static binary. The next thing that we need to do is edit the XML file. I'm going to go into the m5 XML directory, and if you recall, SST is going to look, we're going to tell it to look at example.xml, and that directory, or that file, points to example.m5.xml. So we're going to edit example.m5.xml. Again, gedit. Alright, so here what we have is the executable is being labeled as m5exe, so no change is needed there. But what we do need to change is the command line arguments. So if you remember, hello didn't need any command line arguments, but now we do. I'm going to look for cmd.0. And I just need to throw in the command line switch here. So it's going to be command 1, and it's going to be -b1. This is our first command line argument. And this command.0 shows up twice, so we need to edit both instances of it. Alright, so now if we do a search for cmd0 in the example m5.xml, there's two instances of it. This one here and the one that we edited previously. So since we've already set the m5_exe variable, that's all we need to do. Again, my current directory that I'm in is the m5xml path, because that's where this XML file resides. And we're just going to send in our sst binary. We're going to tell it the XML file we're using, and then we're going to run this. So this is the initial execution of m5. It's reading from example m5.xml and it's starting up. And then this right here, ramspeed 2.6.0, this is the program starting. And again, it's going to do, I'm going to scroll back here in my command, and eventually what we're going to hopefully see are all these different size blocks being sent into memory and written. However, this will take about 8 hours. That's my estimate on the machine that I'm using. Each line that we saw previously up here, each of these lines will take about half an hour on my machine because you're running in a cycle-accurate simulation. So I'm not going to let this finish out while we're talking here, but that's the idea. And at the end, the gem5 will terminate syscall emulation mode.